Hello everyone, in this video I'm going to be talking about how to predict all the monochlorination products in a free radical halogenation, or another way of saying free radical chlorination reaction. So whenever you are given the reactant, the chlorination is not very selective. It's more reactive, so you could see multiple products of an monochlorination. And to be able to determine all the multiple products, first be able to identify the different types of carbons you got on your reactant. So starting from the left side on the reactant, I got this right here to be the primary carbon, and then I have this right here to be the secondary, and then you have this right here is to be the quaternary. Now quaternary carbons does not have any hydrogen, so they are not going to have any chlorine installed on them. And then you have on the top, you got these primaries. So that's another two right there. And then you got this tertiary, and then you have another two primaries right there. Now, also remember that some of those are duplicates, or another way of saying some of those metal groups or primaries are actually equivalent. For example, this top set right there, oops, this top set is an equivalent of one another, and then the set on the right side of those primary hydrogens, carbons are also equivalent. So whether you put it on either one of those, is going to be giving you the same product. Now let's start drawing the actual products that you're going to be getting from those reactants. So I'm going to go ahead and copy this down, duplicate that right there. So I'll start from the left side. I'm going to go ahead and erase the rest of it. So when I'm starting from the left side, also worry about if you're going to be getting any chiral centers or not. So on the left side, I'm going to have my first chlorine right here. So that's going to be one of the products. Now remember, this chiral center is not, this carbon is not a chiral center, so I don't have to worry about drawing the stereoisomer of that. This will not have any stereoisomer. So that's one of them. Okay, let's see what other possible constitutional isomers I can get. I'm just going to go and copy that down here. Just erase this. Now I'm going to go ahead and get onto this secondary carbon that I got here. So I'm going to replace the hydrogen from there. So when I replace the hydrogen from there, I'm going to be getting one chlorine, obviously, and there, but that, also remember this carbon is actually in a chiral center, so you could technically have either the chlorine coming out of the page, or you could have a chlorine going back in the page. So those are going to be your a pair of enantiomers technically. They're not really constitutional isomers of one another, but there are a pair of enantiomers, so you could possibly see those two products right there. So when they ask you to draw all the possible products, you would have to draw all the constitutionals and all the possible stereoisomers in there. So those would be the enantiomers of one another. Okay, moving along, let's see what else we got. We're not really going to have anything on the fourth carbon, on the quaternary carbon here, because it does not have any hydrogen. When you look on the top one, both of those metals are equivalent, so I will be replacing only, on one of those carbons. So let's test that out. So I'm just going to copy this down right there. So I could go ahead and have a chlorine here. So that's not a chiral, so I don't have to worry about drawing another stereoisomer of that. So that's that. And then what else we got? We could also have a chlorine right here. So when we put the chlorine right there, let me just go and copy that down here. That would be looking like this. That's not a chiral center, so I don't have to worry about drawing the stereoisomer of that. And then finally, you also have one more position where the chlorine can be installed, and it'll give you a different constitutional isomer, and that's going to be your right methyl group. So either this one or that one, any one of those would give you an equivalent product here. So you don't want to be drawing two different ones where you, in one case you installed chlorine here, and in the other case you installed chlorine here, because those are all going to give you the same product. So then I would have chlorine here. So that's how many um, constitutional isomers and stereoisomers you're really going to be getting after doing the monochlorination on this particular alkane. Okay, let's do maybe one more example. So if I have suppose this guy right here, let's see what we're really going to be getting on this. And remember, you cannot do a chlorination or free radical on the benzene ring, so don't remove any of the hydrogens from the benzene ring. It's just going to be this particular group right there. And when I'm looking at this particular group, I got a primary carbon right there. I got a tertiary carbon right there. I got a secondary right there, and I got a primary again right there. And they're all actually different from one another. So since they're all different from one another, you could get chlorine installed on every single one of them one by one, and you may also get some chiral centers in there. So let's say we can have chlorine onto this carbon, so that's going to give you one of them. And now let's see, I'm gonna go ahead install the chlorine onto this tertiary carbon. Now, once we install the chlorine in there, that's actually going to be in a chiral center, so we could technically have that chlorine coming out of the page or going back in the page. And in the process, that would also make this methyl go in or out of the page. So that's this. And then I can say, okay, my chlorine is going back in the page. So that's one product, and obviously I can draw the enantiomer of that. So when I draw the enantiomer of that, that's going to be, so I could have um, chlorine coming out of the page here, and I could very well have the methyl going back in the page. So those two are going to be the stereoisomers, or another way of saying they are going to be the enantiomers of one another. Moving along, what else could I do? I could also install your chlorine onto this secondary carbon right there. So when we install the chlorine onto the secondary carbon, this will become a chiral center. So I could have the chlorine here either coming out of the page or going back in the page. So I could, in one case, suppose if I have this coming out of the page, then I could very well have this going back in the page as well. So those two are going to be the stereoisomers of one another, or they are going to be the enantiomers of one another. And then finally, I can also install the chlorine onto this primary carbon that's onto the right side, and that's not really going to be chiral, so I don't have to worry about drawing the stereoisomers or any other form of stereoisomers in there, or the enantiomers in there. So I can just go ahead and put chlorine there, and that's pretty much it. That's how many monochlorination products you're really going to get. That's including the constitutional isomers and the stereoisomers on this particular one. And remember, you're not going to be touching anything or not going to be doing anything to this benzene ring because they don't do the monochlorination, or they don't do the free radical halogenation.